Okay, this is a supplementary video for the EIGRP concepts. In this video, I'm going to calculate metric with using the mathematical formula and then testing that to see if it is okay in the router's console. We have a scenario with 3 routers and 1 destination. 2 links are gigabit interface with bandwidth 1 million kilobit per second. And 1 link is fast Ethernet with bandwidth 100,000 kilobit per second. Alright, let's do it. Okay, in this scenario, we have already configured EIGRP on it. Now we are going to measure the metric in each hub or router for destination network A, I mean 192.168.10.0 with /24 through the formula. And then we show the metric in the routers to see if we did it correctly. First of all, here are TT or topology tables, which is used by the router to calculate metric and understanding the whole topology. We're writing down the info in TT or topology table, and then we replace the numbers in the formula for your better understanding. Now we start from the nearest hub, router 1. This is gig interface. What is the bandwidth? Right, 1 million kilobit per second, right? And what is the delay? Because this is gig interface, the delay is 10 microseconds, right? And how many hops to reach the network A? There is no hop, so 0. Now it is time to replace the values, so metric equals 256 times 10 million divided by 1 million plus total delay divided by 10, and the answer would be 2,794. Now router 2. We draw TT or topology table for network A. What is the bandwidth? This is gig interface, so it is 1 million kilobit per second. And what is the total delay? It is 10, but listen, but we must add the next hop's delay, so it is gonna be 10 plus 10. As a result, total delay on this link is 20. And how many hops to reach the network A? There is only 1, right? So now if we replace the values, metric would be 3,072. Now router 3. We draw TT. What is the number of bandwidth? As you know, this interface is fast Ethernet, so bandwidth is 100,000 and delay is 100 microseconds. So we have to add 100 plus 20, the next hop's delay, right? So total delay would be 120. How many hops are there? Right, 2 hops. If we replace and calculate, metric will be 28,672. Now it's time to test the answers to find out that we calculated metric correctly. To start the task, we need to see TT or topology table. So we're going to the nearest hub, router 1 right here. To show topology table, we input show IP and routing protocol. What is the routing protocol? It is EIGRP, and then we input topology. And after that, you can input the specific network to see that. But right now, I want to see all the links, so I input all -links. And then here we go. You can see all the successors right here, but we have worked with this one, network A, which is our feasible distance, and this is our metric number, which is 2816. Don't concern about the difference between metric calculation in the router and our answer. This difference is because of the emulator, so don't care about that. It is not that important. Our answer for router 1 is okay, and our metric calculation is right. And now it's time to go to router 2 right here. As always, we're going to show topology table. Oops, show IP, EIGRP, topology, all links. Now here we go. This is TT or topology table in router 2. And as you can see, network 192.168.10.0 with the /24, which is our network A, calculation metric is 3072 for the feasible distance. You can see that, right? So our answer for router 2 is okay. Now we calculated the feasible distance metric calculation for router 2 correctly. And now it is time to test the answer for router 3. Right here, which the interface is fast Ethernet. The metric number is supposed to be bigger number because this is fast Ethernet. Way bigger because the bandwidth is smaller. We're going to show TT or topology table. All links. Here we go. You can see the feasible distance for network A, and as you can see that the number of metric for this network in router 3 is 28,672, and we did it. We calculate the metric right. Thank you guys for watching. I hope you enjoyed that. We're going to dive into EIGRP configuration in the next video. We will configure EIGRP in a very practical laboratory in 2 different ways, in 2 different modes, in named mode and classic mode. So you will fully familiar with EIGRP configuration. So wait for it. Thank you. See you soon.